Hello, my name is Devina Tracy, so I'm going to present for question 1.
For question 1A1, we need to prove our answer in manual calculation, that is, the type of this equation is homogeneous equation. So to prove that, we will use MATLAB to simulate the answer. We use sims, variable x in terms of t, ODE equals to t times derivative of x in terms of t equals to, in bracket, 3 times t to the power of 2 minus with x to the power of 2 divide by, in bracket, t minus 2 times x. Next, solve it. In bracket t equals to d solve, in bracket ODE. So this is the answer we get. Same with the manual calculation. Here we can prove that the type of equation in the question is a homogeneous equation. For question A2, we need to justify our answer in calculation, that is, the type of the differential equation is an exact differential equation. So there are two variables that we will use, that is variable x and variable y. Since x to represent x, since y to represent y, then we assume m as 1 minus 2 times y minus x. Next, we assume n as n equals to negative 4 times y minus 2 times x. After we set the values in m and n, we find the derivative of m in terms of y. So, derivative m in terms of y and derivative n in terms of x. Here we can see that both derivative of m and n are both negative 2. Hence, we know that this equation is an exact differential equation. So our answer in calculation is true. Then we can solve the exact differential equation. Firstly, we set w equals to integration of m in terms of x, and then we get the answer. Next, we let r, derivative of w in terms of y, then we let s, n minus r. Next, t as integration of x in terms of y. Then to get the final answer, we let g equals to w plus t. This is the final answer of the exact differential equation. Here we can see that we get the answer same as in the manual calculation. For question 1b, we need to verify that the solution for the equation yx dy over dx equals to 2 in bracket y squared plus x squared, and the initial condition of y in bracket 2 equals to negative 1 given is true. We can identify it by running the simulation in MATLAB. Firstly, we declare the variable since y in terms of x, and then we put in the equation dA equals to y x derivative y x equals to 2 in bracket y square plus 2 square, x square, followed by the initial condition y in bracket 2 equals to -1, and then we solve the equation. This answer obtained in the simulation is the same with the answer we get in the manual calculation. To solve question C1, we can use MATLAB to run the simulation to get the answer. So firstly, we must declare the variable. And then we must declare the equation. And then we can solve the equation. The answer here is the same with the answer that we obtained in manual calculation. To solve question 1C2, we can also use MATLAB to run the simulation to get the answer. So firstly, we need to declare the variable. And then we declare the equation. And then we solve the equation. So this is the answer that we obtained from the simulation. From here we can verify that the answer is the same with the manual calculation. Then we must use the initial condition. So to find the answer, first we need to declare the initial condition. And then we solve the equation and use the initial condition. So here is the final answer. We get the same answer as in the simulation.
Hello, my name is Nura Alia Farisha binti Halim and I will present to you question number 2. So this is the manual calculation that I made. So we continue with the simulation that I do using MATLAB. The first step that I do is define that the simulation equation have y and x, while the second step that I do is let ODE equals to the equation from the question number 2, which is y double prime minus 6y prime plus 13y equals to exponent x. You can see in the equation that I made, for y double prime, I put as differentiation bracket y, x and 2 because the degree of double prime is 2, while for the y prime, I do differentiation y and x only because its degree is 1. So to get the solution for the equation above, we have to use y solve bracket x equals to p solve bracket ODE. So after I entered the equation, we can see the solution that I get from the equation of ODE. So this answer is not simplified yet. To get the simplified answer, we have to use simplify bracket d solve bracket ODE to get the simplified answer from the solution above. So the answer that I get is the same as the manual calculation, which is 1/8 exponent x plus constant 1 cos 2x exponent 3x minus constant 2 sin 2x exponent 3x. Thank you.
Assalamualaikum and Hi to Madam Shah. My name is Nur Adila Adha Mita Obaka from Group 7. Today I would like to present to you a simulation of question 3 of ODE assignment. For information, I already do it by myself, decode and do it in a draft like this and simulate it successfully. And as you can see too, the code quite long, and I think this gonna take a long duration, so I think I will just copy and paste and simulate it to you that this simulation is successfully done by myself. Okay, without further ado, let's do it together. So for the question 3.1, this is the question stated in the assignment sheet. And hashtag means the comment. It will not execute in the simulation. First thing first, we will find the value for y prime. Y prime equal to ay. So this is the form of the matrix. And then after that, we will gonna find the value for the lambda. We will use this command, which is with lin ALG, which is linear algebra. To make it execute the code successfully. Okay, this is our A, 6152. Okay, and then this is the equation. Find the eigenvalue, which is 7 and 1. This is the quadratic equation, and this is the eigenvalue 7 and 1. Next, we will use again linear algebra command. and we have to state again the value of A. Oops. And then from the A value, we will form the equation 1. This is for the lambda 7 in order to find the value of V1. Okay. We have to form the V1 first, and then we will solve and find the value of x1 which is equal to y1, and then y1 is equal to 1, and lastly we will get the value for v1, which is 1, 1. Next equation in matrix form for the lambda 1. And then the form of v2 and we will solve the matrix by getting y2 is equal to negative 5x2, which is x2 is equal to 1, and we will get the value of v2, which is 1 and 1 negative 5. And then we have to state the YC form. YC, and yeah, that's all for the question 3.1. Next is the question 3.2. Question 3.2, and this is the value, the value of the question, which contain the value of G. In this question, the G is exponent in exponent form. After we identify the form of of our G, we have to form the YP equation. YP is equal to exponent 7x u x1 plus v1 u x2 plus v2. And our YP is equal to our YC, so we have to differentiate it. And we will get this. There's plus e exponent 7x u1 u2. In order to search for the YP prime value, we have to calculate by A multiplied with YP plus G in matrix form. And this the form of it, and we will there's gonna two value, which is x multiplied with exponent 7x, and the one is exponent 7x. Firstly, this is the equation for x multiplied with exponent 7x. The equation 1 that we will get from the real calculation, 7u1 is equal to 6u1 plus u2. And then the second equation is 7u2 equal to 5u1 plus u2u plus 2u2. And then we have to solve it, and we get u1 equal to u2 and u2 equal to u2. Then we state the value of u1 is equal to s, and u2 equal to s. That means it's going to be 1, 1. Okay. Next, for the equation for exponent 7x, the first equation here we form it as equation 3, which is equal to 7v1 plus s equal to 6v1 plus v2 plus 4. And the second equation, which is equation 4, seven v2 plus s equal to 5v1 plus 2v2 plus 10. And then we will solve it. Sorry, I'm not that fast. Okay. S equal to 5, v1 equal to v2 minus 1, v2 equal to v2. And then we get we state the value for the s, which is s equal to 5, v1 equal to 5, v2 equal to 1 plus s equal to 6. And then call out again the YP matrix. Then we get the answer for question 3, which is the value of y equal to yc plus yp. And then for the last question that involved the initial condition, we will have to state the equation first. Okay. And then in this part, in real calculation, we use the substitution, but in this simulation, I will form the simple equation, which is C1 and C1 plus C2 equal to -3. C1 minus 5C2 equal to -5. And then we solve it. And lastly, it will substitute the value of C1 and C2 in the y form, in the y equation. this is our answer. In the recalculation, y equal to exponent 7x negative 10 over 3 plus exponent x 1 over 3 plus 5 plus 5x 6 plus 5x multiply with exponent 7x. And yeah, that's all. This simulation is finished. That's all from me. Thank you.
Next, I will simulate the answer for question 4a in software MATLAB by using its command window. So first, I will declare the scalar variable of s, and then I declare the numerator equals to s, denominator equals to 1, 2, 4. This is the polynomial of the denominator. And then I can simply change the polynomial of denominator into s. I can simply times equals to poly to denom s, and then the function will become numerator over dens. So s over s squared plus 2s plus 4 is the function for question 4a, and then I will need to inverse the function f equals to I Laplace f. This function will inverse the function of s over s squared plus 2s plus 4, and then the answer is exponent negative t times cos 3 to the power of half t minus 3 to the power of half times sine 3 to the power of half t over 3. And then to make it more understandable to understand, I can ask MATLAB to make the answer more pretty. Just type prettyf, and then the answer is exponent to the power of negative t times cos square root 3t minus square root 3 times sine square root 3t over 3. And then this proves that the manual calculation is the same as the MATLAB simulation for question 4a. Next, I will present the simulation of answer question 4b by using software MATLAB in its command window. So first, I can simply declare the scalar variable of s. I declare the numerator equals to s, denominator equals to 1, 2, 5, 2, 4. I get this number by expanding the polynomial at the denominator of the equation, and then I can change the denominator into scalar variable s only using s, and then f, the function equals to numerator over dens. So the function of the question is s over s to the power of 4 plus 2 to the power of s. The function of the question is s over s to the power of 4 plus 2s to the power of 3 plus 5s to the power of 2 plus 2s plus 4. And then we need to solve the equation by using partial fraction. So FTF equals to partial fraction of f. So this function over here will solve the function of f into the partial fraction. So it gets this, and then it's not over because I need to find the inverse of this. So f equals to, I lap this FPF. And then this is the answer. The answer is 3 cos t over 13 plus 2 sin t over 13 minus 3 exponent to the power of negative t times cos 3 to the power of half t plus 5 times 3 to the power of half times sin 3 to the power of half t over 9, and it's over 13. And then to make it understandable to read it, you can read it pretty fast. And then this is the answer. So 3 over 13 cos t plus 2 over 13 sin t minus, we can bring the 3 here in front. So 3 over 13 exponent to the power of negative t cos square root 3 t plus 5 over 9 times square root 3 times sine square root 3t. And then if we simplify this equation here, I can get the answer back to the manual calculation I have calculated earlier. So that proves that the answer for the manual calculation and the simulation is the same one.
Next, the simulation for question 4C. So in question 4C, the question gave series RLC circuit with the value of inductor equals to 1 Henry, resistor equals to 2 ohm, and capacitor equals to 0.25 farads. So we need to prove that the current flows in the RLC circuit can be modeled by this equation. So from the graph, you can say that ET equals to sin t minus sin t heavy side t minus pi. So by using KVL, Kirchhoff voltage law, we get this equation. So by substitute the known variable, so we get this equation. And then when we simplify the equation, we get this equation. So we can prove that the current flows in the RC circuit can be modeled by this equation. So next, for the question 4D, it asks for calculate the current IT if I0 equals to 1 ampere. So we get this equation earlier in question 4C, and then we can solve this equation using Laplace transform, and then we get this equation. So we need to substitute the IO here with 1 based on the given value of the in the equation, and then we factorize the IS, and then we get this equation. So this equation can be simulated in the MATLAB. So we open MATLAB. Oh my god. So first, when we simulate for the question 4D, we can first declare the scalar variable S, and then if we can see here, we get three equation. So we need to declare in the MATLAB. We have the equation. So the first numerator equals to S. Then for the denominator, so here we have already declared for the first equation. So for the next equation, we can simply just numerator 2 equals to And then here we have already declared for the first equation and the second equation. So only left with the last equation. And then we have already declared the first equation, the second equation, and then the third equation. So we need to plus all of them to get the final answer, that is IT. So the answer equals to F1 plus F2 plus F3. And then just simply press enter. And then we get the answer. But if we want to see it more clearer, we can just type pretty answer. So this is the answer for simulation 4D. That's all from me. Thank you.